right, so we're going to be starting off our new unit with scatter plots. Scatter plots and what we call trend lines. Basically, it's just all about plotting some points and looking for a trend. Does it look like a straight line? Does it look like it could form a straight line? Maybe it's a curvy line. Is it like a positive trend or a negative trend? And it's all pretty obvious once you kind of see how we draw out or sketch out the scatter plot. But before we begin that, we're going to start with this starter, number 4, and all you have to do is find the perimeter. To find the perimeter of a shape, remember that you just have to go around the outside of the shape and add up all the sides. Now this shape is a little tricky. Let's take a look. For instance, on this side, it's pretty easy to count that length is 3. On this side, 1, 2, 3, 4. On this side, 1, 2, 3, 4, 5, 6, 7. And so far we have a perimeter of 3 plus 4 plus 7, but that does not include this diagonal that we have right here. So to find the distance of that diagonal, we would have to use what we call the Pythagorean theorem, right? You have a squared plus b squared equals c squared in any right triangle. And in this right triangle, we have a is 1, 2, 3, 4. B is 1, 2, 3, 4. And so you can go find C, and we talked about this and we're tested on it last week. This is the hypotenuse of any right triangle will equal the square root of the sum of the legs, the sum of the square of the legs, right? So that would be a squared plus b squared. So we can find that C equals the square root of 4 squared, that's one of the legs, plus the other leg, which is also 4 squared. Adding those together and simplifying this just by hand, you could type this into your calculator, obviously. It gives us 16 plus 16, which means that our length of C is the square root of 32. 32 is not a perfect square, so we need to leave that as an irrational number. Okay, your calculator will simplify that a little bit better for you, but now that we know what the length of, let me get a different color here, of this diagonal is, the square root of 32, we need to add up all those 4 sides. This side that we just found, plus 7, plus 4, plus 3 in your calculator. Now I'm not going to give you the answer here because I want to see that on your starter. If you don't do it on your starter, you don't get credit for your starter. So I told you what to do in your calculator. Go and do that now. Finish up your starter, pause the video, and then put your starter away somewhere nice and safe. And then you can come back to the video and we'll start talking about scatter plots. All right, so through the next week, we're going to be talking about scatter plots and trend lines. We're going to be talking about basically plotting and scattering a bunch of points on a graph, right? And we're going to see whether or not we could try to fit a line on it, what we call a good line of fit or a best line of fit. We want to see if it's linear. Maybe it's not going to form a straight line. Maybe it's kind of curvy a little bit, right? Maybe it kind of does one of those instead, and that wouldn't be linear, it'd be non-linear. Maybe it has a positive trend, or maybe it's a bunch of points on a plot that have a negative trend. That's kind of all the stuff we're going to look at over the next couple days, and then by the end of the week, we'll move on into something else in statistics. So you should have picked up a worksheet. It looks like this. It has a couple of tables and graphs on the other side. We got 5 more problems, a total of 5 problems, 3 problems on the back. One of them is not a table problem. Okay, but we're given a table of data, right? A big old table of data here, and then we have to plot those points over here. That's kind of what we're going to start off to do, and then we'll talk about each of these, all right? So I'll show you how to do the first one. I'll show you it over here. The first one we're going to do, what we have is number of customers that we have in an hour, and then we're looking at that comparing to books sold. And I want to know if we have more customers, are we selling more books? And that's what scatter plots and trend lines is all about. If I have more customers and I'm selling more books, great. However, if having more customers doesn't mean I'm selling more books, then just having people in the store doesn't mean I'm going to be selling more books, right? So I need to do something with my business practice or advertising better or whatever it might be. All right, so let's dive in. First things first, I have a graph over here. It has an x-axis counting by ones as well as a y-axis counting by ones, but they're not labeled. So I'm going to go ahead and choose which one I want to be x and y. I'm going to go ahead and label my number of customers as x. So if my x-axis is representing the number of customers, I want to see if my book sales are going up. So I'm going to let Y be my books sold. And sometimes probably wouldn't matter how much, if we're going X's and Y's. However, I will say this, if you are dealing with time like weeks, years, hours, I would always put that on the X-axis. So here we go. I'm going to do a couple of points just because I know some of us are not too strong on graphing those points. So let's talk about this. Each of these points in our table over here is an XY coordinate. An XY coordinate meaning X tells us how far left and right to move, and the Y coordinate is how far up and down we need to move. We reviewed this last week, but we're going to go back through it again right now. First things first, if our X value is 3 and our Y value is 3, that means that first number tells me to go right on the X value, 3, and then I'm going to take that point and I'm going to move it up 3 because I need to be at the Y value 3. So this point right here is representing these two numbers off my table, 3, 3. All right, the next point, 4, 5. Number of customers is 4, and then my books sold is 5, right? And if it helps you, and you probably should do this anyway, label your X and Y values. I just haven't done it yet, but I will. So let's go ahead and label our X values. Our X values over here are going to be the number of customers, and my Y value is going to be books sold. All right. So you can kind of see if we have 3 customers right here, we are selling 3 books, and that's what this first is saying here, right? A first list of information we're given. All right. So let's keep going. I'll do 9, 10. So 9 customers tells me to go over here, 9 on the X-axis. And then I'm selling 10 books at that point, which is 9, 10, which is right here. 7, 8. 7, 8 is right here. 8, 7. It's right here. 6, 6. 5, 5. 2, 3. All right. So that's a scatter plot. It's a bunch of points that don't necessarily make a straight point, like a straight line. So I can't necessarily draw a straight line through these, all the points at once. So it's not like a linear equation, if you will. But it does kind of have that look to it, right? As the number of customers is increasing, the number of books sold is increasing, which is why we have this positive trend here. Right, so we call this a positive correlation, right, or a positive association. As the number of customers increases, so is the number of books sold. So let's go over just a few terms here. So this is the graph we had just a second ago over here. So this is what we're referencing when we're talking about this stuff, all right? So let's take a look at what we have to read. The graph shows data for 2 variables. Our variables were the books sold and the number of customers, right? Now you'll notice here, I graphed it differently. I graphed number of customers versus the books sold. Did it matter? Do I still have that positive trend on both? I do. So I would say that the number of books I sell depends on the number of customers I have. So I would say that books sold is the dependent variable, making it the Y, and then the other variable, the X. But in this case, I think you could interchange X and Y. In this case, we're just saying, hey, the book sold a number of customers is a positive trend. It graphed it differently. It said that the book sold was X and the number of customers is Y. That's okay. Nothing wrong there, all right? But we are dealing with 2 variables. And we're dealing with 2 variables in statistics. We call it bivariate data sets. And bivariate is just 2 words kind of joined together, right? You got bi meaning 2 and then variate meaning variables. 2 variables. And when you plot the data points from bivariate set, you make a scatter plot. And that's what we have right here, a scatter plot. Scatter plots can visually show an association, all right? What we're looking for this year are linear associations. Basically, if I kind of look at that, all those little plotted points there, does it basically make a straight line? If it makes a straight line, then it has a linear association. Another way that we talk about association that's not listed here is, does it have a positive or a negative association? Positive associations go up and to the right, just like positive slopes do, and negative associations go down and to the right, just like negative slopes do. So if you have your slopes down, you should know what positive and negative associations are as well. What we're really adding to that is this a linear scatter plot? Does it have a linear association? So what I would say about this scatter plot is that it has a positive and linear association. Is it possible to draw a line that includes every data point? So we skipped a question there, but is it possible to draw a straight line that includes all of that? Well, the answer is no. We can't draw a straight line that includes all the points, but can we get that line to be as close as possible and to have about 50% of the dots above and 50% of the dots below? I think we could. Something around right there. Oops. Something around right there would be a great, what we call a trend line or line of best fit. All right, take a look at this one again. We're continuing on. We talked about positive and negative associations already, but a positive association is like a positive slope, like if you were to draw that line through a linear association, and then a negative association would be like a negative slope. So here we have a positive linear association. All right, so what I would like you to do is, now that I've done number 1 for you on your worksheet, right, you should have your scatter plot here. You should have your X and your Y axis labeled, and then you should have all your points plotted. And then I want you to tell me the association between these, right? So for like number 1, again, you have all those points on there. You have your scatter plot there. You have your X and Y axis, and then you'll say something along the lines of a positive linear association. Okay, so that's what I'm looking for on all of these. So you're going to try number 2. So you should pause the video. I'm talking about you guys. Pause the video and plot these points, right? Make sure you label your X and Y axis. In this case, the years are counting by ones, it looks like over here. So you're definitely probably going to want to put your years down here. So put years on your X axis, and on your Y axis is the number of attendees, right? Now plot all those points, and then tell me, does it have a positive association? Does it have a negative association, right? Also, is it even make a straight line? Is it linear, right? So add those things. Is it linear, non-linear? Is it a positive or a negative association? Okay, go ahead and try it. All right, so we should be looking at something like this right here. You have the years on your X-axis. You have the number of attendees on your Y-axis. I'll just do a couple points if you're still struggling with points. If at 1 year they had 50 attendees, so right here is 1 year, and then at 50 attendees is this point right here, right? Then you've got 2. At year 2, it was 150 attendees, which is this point right here. I'll do one more for you guys. 3, 250, 3 would be right here, and then 250 attendees at 3 years, right? And so on and so forth for the rest of those points. So what did you say about the association? Well, let's talk about this. First off, is it linear or nonlinear? And I think this one could be argued one way or the other. But for me, I'm going to say that this is nonlinear. And here's why. It looks like, if I ignore these 2 points, it looks as if this is a linear association as well as a positive association. So if you wrote that, I understand why. However, these 2 points right here, we can't just ignore them, right? In this case, we kind of have to accept them. And if I were to draw a trend line, I have to try to keep half of my points above and half of my points below that line. So maybe something closer to this. About there, maybe, would be the line of best fit. But does that line really best fit all of this data? I don't think so. So there may be an association between these. I just don't know if this is very conclusive data. I could see how this is a positive association for the most part, So maybe positive, but I'm kind of iffy on the positive association. I'm also a little iffy on the linear association. So kind of positive, kind of linear association. And sometimes that's just what data looks like, right? I wouldn't make any predictions based off of this. I would just say, hey, there's kind of an association here, but not really. It seems at some point later on down the years, the attendees started to drop off. And it looks like they had a great trend going at first, but then after some time, it turned into a negative trend again, right? All right, next one up. We got number 3. Again, pause the video. Plot those points down there. It looks like it's best to do age. Age is time, right? So age should probably go on the x-axis. Let's see here. It looks like my y value here goes up to 104. So this might be a little bit harder to sketch, but you got 25, which is right here. And then kind of at 104 would be about just right here. You can just be approximate on these dots, by the way, on the scatter plots. It doesn't have to be perfect. Just kind of get it around where it needs to be, okay? So go ahead and try that out. Plot those points, 29, 84. 29 is almost 30, comma 84 is just above 80. Be right there, so on and so forth, right? I would do age here, and then number of social media followers here. So this would be your social media over here, right? Plot away, have at it. Try it on your own, okay? All right, so I got all those points plotted over here. Let's see here, yeah, that 25, 104 is right there. You got the 3860, well, it doesn't look like that's actually, yeah, it's right, it's one of those two right there. But then it's just kind of, approximate. That's okay. Do your best. But what did you guys get for the association? Is this a positive association? Do you see a line that's going like this and trending upward? I don't. I don't see a positive association. Maybe slightly negative if you ignore this point, right? If that was like what we call an outlier, kind of a piece of data that lies outside of the data, and it's far away from everything else, it's kind of just that little bit of an outlier. I don't know. Maybe a little bit negative. I'm going to go with basically no association here, though. And here's why. I don't see a straight line, really. It's kind of all clustered together in this section, right? Number of social media followers and their age, it looks like it has no association. So just because you're old, does that mean you can't get followers? Or does that mean you have more followers? It doesn't look like there's any association or correlation between those two things. That's basically what our data is showing. You can be young and have a lot of followers. You can be young and have no followers, right? Check out my subscription count. I don't got a lot of people following me on my social media. Nope, I don't. And I'm old. So just because you're old doesn't mean you get more followers, right? So that's kind of what we're looking at here in scatter plots. I would say that there's no linear, doesn't really form a straight line, but there's also not a positive or negative correlation. So we just say no association. All right, number 4. Number 4, looks like we're looking at the number of attempts and mistakes made. So I guess probably what we're asking here is, as we increase our number of attempts, how many mistakes are we making on those attempts? So if I made 5 attempts, by that 5th attempt, I'm making 0 mistakes, right? Or on my first attempt, I'm making 5 mistakes. So is there an association between how many attempts I make and how many mistakes I am making? All right, so go ahead and plot all those points. Maybe put number of attempts on the x-axis and mistakes made on the y-axis. In this case, it probably doesn't matter, but go for it. All right, so number of attempts versus number of mistakes. Put number of attempts on the x-axis, like I said, and a couple of points again, like 3, 3, sorry. So if I had 3 attempts, I made 3 mistakes. So that's that point right here. 1 attempt is 5 mistakes. 5 attempts was 0 mistakes. That's that point right there. So on and so forth. All right. It would seem we have a negative trend. So definitely a negative association. And it looks pretty linear. All right, so we have a negative linear association on this one. So what does that mean? The more attempts I make, the less mistakes I make. You should take that into consideration when you need to retake a test. When you go to retake it, chances are you're going to make less mistakes. This is how it is. The more times you do math, the less mistakes you're going to make because you're practicing it. And when you do make a mistake, you learn from it. And so you do it again, and you'll probably make less mistakes because you're learning from your mistakes. All right? So that's kind of what a negative trend is. Is that bad? Is a negative trend bad? No. Negative trends can be good. They could be bad. It just depends on the context. In this case, I think this is a good thing to see. The more attempts I'm taking at something, the less mistakes I'm making. That's a good thing, even though it's a negative trend, right? When we were looking at positive associations earlier, like the year and the number of attendees, it's like, well, as the years were going on, it looked like I was getting more attendees. So that was a positive association and probably a good thing to notice, right? Even though this started to turn a little negative there at the end. But here's the key takeaway. Positive trends don't mean good or bad. It depends on the context. Negative trends, good, bad, it just depends on the context. In this case, it was a good thing, right? It just encourages me that the more mistakes I make, the more attempts I'm probably making, right? And it doesn't necessarily mean one is causing the other. It just means there's something in there that's associated with those two variables. So try again, and you'll make less mistakes. That's a good thing, right? I believe that's it. So last question I have for you from your text on page 698 is, what do you think a scatter plot that does not have a linear association might look like? Now I can kind of sketch that for you real quick. There are all kinds of little trends we could have. I mean, if you want to label an X and a Y axis, you can try to think of something that has an X and Y axis, but something that's not linear but has an association. It might look like a bunch of points that aren't necessarily linear, but maybe something else, right? Something that's not necessarily a straight line. There's an association here in this data, but not necessarily a linear association. Okay, so there are some other ways to talk about data that are not linear. And most of those things you will talk about in 9th grade when you talk about exponential, all right? Exponential trend lines. All right, so take a look at number 5. You can do this on your own. It says this: describe what the association found in problem 1. Problem 1 is this guy right here. I'm going to erase some of this. Boop, this guy. I'll just go to the one I provided you here, right here. There we go. This one right here. The book sold versus the number of customers. And it asks the question, in an hour when there are 10 customers. All right, so 10 customers is right here. Are there more likely to be 4 or 10 book sales? So I'm just kind of following this over here. Is there more likely to be 4 book sales or 10 book sales? If we're following this trend line, it looks like there's going to be 10 more books, right? 10 books sold as opposed to 4. 4 books would be right here, and we can predict that if I'm selling 4 books, I probably had 4 customers. That's making predictions using the trend line, right? If I had, let's say, 7 books sold, how many customers did I have? About 7. It looks like a 1-to-1. Every customer that comes in buys one thing, right? So that's kind of how we use predictions there, and to answer number 5. So put that in your own words, answer that question. Make sure you got everything written down in the book that you need. Make sure you have this whole worksheet filled out, all right? And that's it. That's scatter plots and trend lines, guys. And as always, have a good one.